All right, so mic is on. Always good to double check the audio part is also hooked up correctly.
Assuming nothing shorts, it never hurts. I said, assuming nothing shorts, it never hurts.
Come on. There we go. Little windscreen. All right. Is it on? See.
I think I hear it a little.
Oh.
It's great. All right.
Now it should be on. Yep. Here we go. Okay. So let's go ahead and get started. Are there any questions about the exam on next Tuesday for this class? Yes?
Can we go over the exact exam one practice questions that were from the one that you gave us on Tuesday?
Okay, sure. We will go over those are the practice exam because they were the practice exam for the previous semester. Okay. Let's see, where are those? Are they in the? Okay. All right.
Sorry.
This is the actual. This is the practice. There we go. Okay, so question number one is a whole lot easier than the other one because we just have to look for the duplicate items because the set X cannot have duplicate values. So you can see that 1 is duplicate, 5 has a duplicate, but the other ones do not have duplicates. So the final set is going to have 1, 5, 7, 0, and 4. Okay? So the cardinality is just counted how many things are actually in X. So then they're just 5. Question number 2, subtraction. Quote unquote subtraction is whatever is in the first set that is not in the second. So in this case, 2 has to be taken out, 4 has to be taken out. So after the quote unquote subtraction, 1, 3, and 5 will be in the result. But the result is a set, so you have to use curly braces around it to indicate it is a set. Question number 3, given any two sets A and B, we worked on this one already last time, so it's an empty set. Question number 4, given that F is a function mapping from domain D to codomain E, the cardinality, we worked on this one too, F itself and D, they must have the same cardinality. Question number 5, F is a function. It maps from real numbers to real numbers. The funny looking R is representing real numbers. And we define f of x as x squared in terms of subjectiveness, not subjectiveness, it's surjectiveness, injectiveness, and bijectiveness. What do you think?
So you just want us to state if it's injective or not?
Well, is it surjective?
It is surjective.
It is non-surjective because the square of a number cannot be negative, and yet there are negative numbers in real numbers. So it cannot be surjective. It is injective. Every different number in the domain will map to a unique number in the codomain. The answer is no, because 1 and -1, they both map to 1, because the square is always positive. So because at least one of those two is not true, so it cannot possibly be bijective. So it is not surjective, not injective, and not bijective. So the answer no to all of those.
Why is it non-surjective?
Why is it non-surjective? Because negative numbers are not used in the codomain. These are not complex numbers, so you can never have the square of a number being negative. Now, on the other hand, if we are not dealing with real numbers and we're dealing with complex numbers, then the answer will be different. Okay, question number 6, in propositional calculus, the little negation symbol is an element of which set? Omega, yeah, that's all the connectives. Question number 7, using only the axioms, prove the contrapositive theorem. P implies Q is really saying exactly the same thing. It is equivalent to not Q implies not P. So you will have to use those rules that we talked about in class, to prove this one. You guys want to do it?
Yes, please.
Okay. All right. So let's use a mouse pad. I probably won't name the actual axioms, but I can do it step by step, so that each step, I can tell you what it is, what is the mechanism, but I don't have the numbers to refer to. Okay, so we start with P implies Q. So by definition of implication, we end up with the negation of, take it back, the negation of P or Q. Okay, that's by definition of implication. There we go. All right, so once you have that, then what you do is you can apply double negation. Actually, you don't. You just change the position here. So it becomes Q or not P. Okay, and this is by commutative property of disjunction. There we go. Okay, so once we have this, then we can use the definition of implication again, where you negate the first item and then you keep the second item non-negated, and then you replace the disjunction with an implication. So this is the last step. The last step is really just saying, okay, let's negate the first one, not Q, implies not P, or implies not P. This is once again, by definition of implication. Did everybody see how the last one, why the definition of implication is applied here? Anytime you have a disjunction, you can turn it into an implication by replacing the first item with the negated version of the first item, and change the operator or into the operator of implication. So that's the actual proof. 3 steps. All right, so this is for question number 7. Question number 8 is to use a truth table to prove exactly the same thing. So what you do is you expand it. You expand the first one, you expand out the second one, and then you make a truth table. And from the truth table, if all the rows have exactly the same value, then the 2 expressions are equivalent. So you have to make the truth table.
So, for example, it would be like for P, it's 0, 0, 1, 1.
Yeah, so it would look like this. You have P and Q as independent variables. Then you have P implies Q being 1. And of course, you can always spell it out, as not P or Q, okay, because these 2 are exactly the same thing. And then you have not Q implies not P as another column. So if you can prove that all the values of this column are the same as the values of this column, then you have just used a truth table to prove 2 expressions are the same in Boolean logic. Okay, is that helping or? Okay, all right. Any questions up to this point? Yep.
Will it give us the value for P and Q for that case? For the truth table?
Oh, okay. So to make it, okay. How about you guys help me out and fill this in?
0.
Okay, 0, and what about Q?
0.
Okay, it doesn't really matter what order, I just need to have all the combinations.
0, 0, 0, 1, 1, 0, 1, 1.
There you go. It doesn't have to be in that order either. Okay, I just need all the possible combinations of true, false for all the variables. All right. Any other questions about number 8? Okay, here's number 9. So number 9 is very similar to the other one that we saw earlier with some little differences. R1 is less than or equal to, R2 is greater than or equal to. So first of all, let's take a look at R1 and R2. Are they reflexive? In other words, ARA exists in both R1 and R2. It is true.
Sometimes.
Yeah, so it is reflexive. It's always the case. Pick any number in Z, which are our natural numbers, okay? Is that number less than or equal to the same number? Is that number greater than that number? Yes. Greater than or equal to, sorry. Yes. So they are, so it's reflexive. Okay, reflexive is just A or A. Okay, for all the elements A in Z in this case. Are they symmetric? A or B implies B or A. They're not symmetric. Are they transitive? A or B and B or C implies A or C. They are in fact transitive. But because we missed one requirement of symmetry, they are not equivalent. Okay, so that applies to R1 and R2. Now we will go ahead and define a new relation, R3, which is the intersection between R1 and R2. Okay, so now I'm going to do the same thing with R3. So with R3, first of all, what is the more common name of R3? Equivalence, or equal to. Okay, if you like to use the operator equal to, okay, that's fine too. Equivalence is the same thing. So with that one, is it reflexive? Is every number equal to itself? They're all equal to itself. Is it symmetric? A equals B implies B equals A. Okay, are they transitive? A equals B and B equals C implies A equals C. And as a result, they are also equivalent. Equivalency is meeting all the other three requirements. Okay, are there any questions about number 9?
So when you say A relates to B, are you comparing the all natural set of Z itself, or what is A and B?
Okay, so A or B, assuming R is a relation. Okay, so remember what a relation is. A relation is a subset of the Cartesian product of two sets. Okay, so let's say we're dealing with natural numbers here. So it's Z cross Z. Okay, so in this case, this means it's really saying the same thing, that AB as a two tuple is an element of R. That's basically what it means. When this is a shorthand, because this takes a little longer to write. That's all. Right? Are there any other questions about number 9? No, number 9 is good. Moving on to number 10. Number 10 is the last one. I am not going to talk about this one because we have not talked about countability of sets yet. So that's fine. We won't have questions related to number 10. Let's see, there's number 11. Oh, number 11 is good. This one, okay. What we understand as a binary number is merely a representation of the value using base 2. As such, there is a mapping, there's a function from the Cartesian product of 0, 1 as a set to the values that we want to represent. So this is a 4-bit number. Okay, as a 4-bit number, when I use a power symbol like this, it means it's a Cartesian product. It's 0, 1 cross 0, 1 cross 0, 1 cross 0, 1. Okay. So we end up with a 4-tuple. Each item inside the 4-tuple can either be a 0 or 1, which we also know as a 4-bit number. Okay? And so there is a mapping going from a 4-bit number, binary number, to the values of 2 to the power, negative 2 to the power 3, which is 8, to 2 to the power 3 with minus 1, which is 7. Is that okay so far? So do you guys want me to kind of spell this out a little more? Spell it out? Okay. Okay, so let's go ahead and spell it out a little bit. So I will display the function on the top here. And down here I'm going to say, okay, f is basically saying 0, 1, 0, comma 1 cross itself 4 times. That's what to the power of 4 means. It's basically the Cartesian product to itself 4 times. Okay? So I'm looking at this whole thing, and the function is mapping this to the values, in this case, negative 8 to positive 7. Is that okay?
Is that just going down by 1 as well with the codomain? It's like -8 to -7 to -6 onwards up to 7?
Yeah, yeah. So this is an inclusive range. You know, it starts with -8 on the low side. It ends with +7 on the positive side. Okay. So what we want to do is to find out, okay, what exactly is the domain? Okay, the domain is the Cartesian product of 0, 1, except we're doing it 4 times. So each element in here is basically a 4 tuple. I can say it starts with 0, 0, 0, 0. The next one can be 0, 0, 0, 1. Now remember, I'm only using this order because this is usually how we enumerate the elements, okay? But there's no such thing as ordering of elements inside a set. So I just chose this rather natural way of enumerating the elements. But remember, there's no actual order in the set. Are we okay so far with what is in the domain? The codomain is just the values, -8, -7, -6, all the way to +7. And there's a function to do this, okay, to map it 1 to 1. So let's go back to the question and find out what you are asked to do. Okay. So the function can be defined like this. So we are basically mapping function f is a function, and the way we apply the function is that it has 4 parameters. A is 0 or 1, B is 0 or 1, C is 0 or 1, D is 0 or 1. So a closed form of this equation is to multiply D by 1, multiply C by 2, multiply B by 4, and multiply A by 8. Well, this is minus A times 8. That result will give you the value. We can plug in a few things and see if it works. Okay, so let's pick out maybe 1, 0, 1, 0. Okay, so 1, 0, 1, 0 is definitely in the domain because it's a 4 tuple. Each item in the 4 tuple is either a 0 or 1. So now we apply f to 1, 0, 1, 0. We just do it as a regular function. So because A is a 0, so there's a 0 for the first item. Okay, this is no good anymore. So we have a first 0, and then we have C is a 1, so we have a 2. The other one is a 0, and then the last one, which is this guy here, this is A. A is a 1, so we have a -8 here. So when you add up all these numbers, we end up with -6. Okay, yep.
Does the domain have to be 0s or 1s?
The domain or codomain? The domain is not 0, 1. The domain is a 4 tuple. Each item in the 4 tuple is 0 or 1.
0 or 1.
Right, because this is how it looks like. This whole thing is our domain. Is that okay? All right. And some of you are in my next class in CISP 310. What does this remind you of? 2's complement. Okay, if you take the 2's complement of 1010 as a 4-bit number, you will get 0110, which is the representation of 6 as a value. Okay, so there's a strong correlation between math that we learned in this class and also other things that you do in your other classes, including assembly language programming. All right, so getting back to here. So the first question is this function injective? In other words, every element of the domain gets to map to a different element in the codomain.
Yes.
It is injective. Is it surjective? In other words, do we use up all the values, all the elements in the codomain? It is surjective, and as a result, it is bijective, because the definition of bijective is a function is both injective and surjective. So there is a 1-to-1 correspondence between 4 bits and the values -8 to +7. Is that okay? So the next question is to ask you, because, well, if it is bijective, so this is a very strong suggestion that it is bijective, otherwise I wouldn't ask the second part of this question. So if it is bijective, what is the inverse function in closed form? In other words, I want you to give me an answer kind of like this. You give me a for tuple, and then for each item in the for tuple, you give me some sort of formula that will get me the 0 or 1 for that position. Okay? So how do you do it? In other words, I want to apply f negative 1, the inverse function of f, to the value of negative 6. In closed form, I want to end up with 1, 0, 1, 0. So how do I express these items as a formula?
Using the function that was given already?
You can't, well, you cannot quite use the function that is given to you already because this one only goes in one direction. So you have to apply, something else to give you this closed form. What do you think? Using only operators that you have learned in C and C++, how would you deal with this? Okay. I heard if statement because you have to look at the sign. The sign is important. Okay, very good. So that's a very good first approach. But how do you do if as an equation, as a formula? That's why I said C and C++, because if you ask a math professor, the math professor will say, there's no way we can do this because we have to use if else. But if you know C and C++, there is a way to do conditional stuff and stay inside an expression. What is that thing called? It's called a ternary operator. Okay. It's the dreaded ternary operator because most people look at this and go like, oh no, not that again. Okay. All right, so I'm going to do this on the projector because I think it's best to capture it. So then I can use this for the next exam, not this one, but the next one. Okay. All right, so let's take a look at f inverse. Okay, I'm going to use prime to mean inverse. A certain number, I call it x. Okay, and it has to separate into 4 individual things. So what I'll do is I'm just going to say this is a of x, this is b of x, this is c of x, and this is d of x. Then I can define those things later on. Okay, a of x. Okay, how do we get the most significant bit given a particular signed value? Remember, you can use the ternary operator.
Wait, that word you say?
Huh?
You say ternary operator? Or?
Ternary operator. You can make use of the ternary operator. You have not learned this operator? I'm not going to ask who taught CISP 360 in your case, for the sake of that person. Because this is a very useful operator. Okay, most people look at this and go like, but I can use conditional statements to do exactly the same thing. Yes, you can, but the result of using a conditional statement to do what can usually be done with a ternary operator will end up with more bulky and unnecessary code. That's my opinion. Okay, but it is a defined operator in C and C++. The other thing about learning these operators is, even if you do not intend to use the ternary operator, when you are hired as a developer, there are chances that you have to read somebody else's code. And you cannot tell someone else and say, you are not allowed to use ternary operator either. Because that person may have left the company 10 years ago. And you're left with the legacy code. So it is important for us to understand all of these operators. Okay, so let me first explain what a ternary operator does. The ternary operator is called ternary operator because it has 3 parts. The question mark separates the first part from the second part, and then the colon separates the second part from the third part. Okay? So the first part is a condition of some kind. Okay, I'll call this C for condition. The second part is some kind of a value, V1. The third part is also some kind of a value, we'll call it V2. Yep.
Perhaps doing it on there so people.
Okay. Okay, so we have C question mark V1 colon V2. So this ternary operator.
Wouldn't it be better to just write
true for V1 and false for V2 because that's how it works? You know?
Well,
Instead of putting V1 and V2. I mean, unless
the
you
overall
have a negative
condition
in
does
there.
need to be true, but what if the condition is
Okay.
knotted, so you wanted it to be false?
Okay,
Then it
this-
gets confusing.
Expression evaluates V1 if and only if C is non-zero.
Yeah.
Non-zero. And obviously the other part is it evaluates V2 if and only if C is in fact zero. And I should say evaluate and returns, because that ends up to be the value of the entire expression. So evaluates and returns it V1, V2. There we go. Sorry, go ahead.
Does it evaluate C or V1?
Say again?
Does it evaluate C or V1?
Subsequently.
So it will evaluate C and return.
It will first evaluate C as a condition, and then depending on whether C as a condition, if it is non-zero, then it will end up evaluating V1 second, and then use the value of V1 as the value of the entire expression. On the other hand, if C evaluates to zero, then it will evaluate V2 as an expression, and then use that particular value as the value of the entire ternary operation, or ternary expression.
So would C be, whatever, A?
Yeah, so,
Talk about A plus 8 greater than 0.
oh, A is easy. A is just saying, okay, if X is less than zero,
Okay.
then it is a one, if not, it is a zero. Because of the way we weight the A, B, C, and D, if A is 1, it is multiplied by 8. Even if B, C, and D are all ones, they only add up to 7. So you still end up with a negative value, even if all the other ones are ones. So that's why, if you know that the value in X is negative, you know for sure that A is a 1 already. Is that okay? And if you're in my next class, you will also see A as a what bit? The sign bit. Because when it is 1, the whole value is negative. There we go. Okay, so with A out of the way, what is B? Bx is, these ones are easier in a way, especially if you know how to use bitwise operators. Because when I say you can use C and C++ operators, that would also include bitwise operators. So if you are allowed to use bitwise operators, how would you use a bitwise operator here so they can come up with Bx, rather quickly? Quick reminder. Okay, this is a bitwise operator. This is a bitwise operator. This one is a bitwise operator. This is a bitwise operator. Let's see, am I missing anything?
Sidestep.
Doesn't it say at the bottom?
Well, these are bitwise operators too, if you want to use those.
Did you just say we can't use bitwise operators?
You can, allowed.
Well, if you side.
Oh, it says you cannot?
What about
Does it say that?
All operators and that excluding all bitwise operators.
Okay, excluding all bitwise operators. Okay, all right, fine. Okay. You cannot use all
that was
bitwise
good.
operators. It will still be pretty easy though.
What's the easiest way to get a 0 on this? Use bitwise.
Okay. Think about, okay, now we can handle the sign, right? We can deal with the first bit, right? So we can reverse the effect of the first bit, or bit A. Okay, let's get back to the solution here. So B, so the first thing you want to do is to take care of the sign first, okay? So you want to take that out of consideration. So what you say is if X is less than 0, then whatever we consider is going to be based on X plus 8. Is that okay? So we do something, okay, so I'll put parentheses around here. I'll say, do something with 8 plus X, and then over here we do something with X. Okay, what am I doing here? Because if x is less than 0, I already know how to take care of that. By adding 8 to it, I get to the absolute value of x. That's how we do it. Okay, you know, we're trying to get to the absolute value. Then you can use comparison again to figure out whether bit b is a 1 or 0. Okay? But this is the idea. I'll leave this one here and then expand on the idea on the next line. Okay? So this is the next line here. The next line says, okay, if x is in fact less than 0, then what we'll be doing is we'll be comparing 8 plus x with 4. Yeah, if it is greater than or equal to 4, then
Are you trying to do like a nested ternary operator?
oh, okay, I just thought of an easier way to do this. This will do too. Okay, you go to this number, you just divide it by 4. Colon x divided by 4. There we go. This is the quickest and easiest way to do it. Because remember, we are talking about C and C++ operators, right? In C and C++, what is 7/4?
So we're assuming these are ints.
Yep, exactly. They are integers.
Oh, is that part of the question? It's just an int.
You can, well, if you're not really sure, you can always say that, right? That's also a C, C++, operator, typecasting. But the idea is this, okay? The idea is you're taking the quotient of the division and not to deal with the decimal point. If you don't want to do it this way, okay, so let's say some of you are more onto the math side, you can do the floor. That's exactly the same thing. Is that okay? I don't remember you talking about the floor function in this class tag. I did.
You did. I remember that.
Okay, so that's one way to do it. So if you prefer that solution to be absolutely clear that we are taking the floor function of that, just write down the floor. Okay, and that would do it. FLOOR, there we go. There we go. Oh, extra, I don't need these parentheses. There we go. Yep.
So your ideas for each letter value is kind of stacking on top of each other. Like you use the question from A to determine from 1 to 0, and then
not quite, because when you look at bx, it does not refer to ax. It does borrow the technique of first checking whether x is less than 8 or not.
because A minus 8 is, or A times 8 is A. That's why we're
Right, we have to take care of bit A first.
okay.
Yep. Okay, but C is a little bit harder. Okay, when you look at C, it's going to be a little bit harder because this is the bit that is in the middle of the entire thing. Okay, it does not determine the sign of the number, and yet it is right in the middle of something. Okay, so what am I going to do with this? First of all, I still have to use the same technique by taking the absolute value of x. Okay, but once you take the absolute value of x, you end up with a 3-bit number. And with a 3-bit number, how do you extract the bit right in the middle? And you cannot use bitwise operations. You can always do a mod followed by a division. Okay, so what are we going to mod first? So it's going to be a floor of something, and the other one is going to be a floor of something. Okay, so we know we're dealing with 8 plus x because that's the absolute value of x. Okay, next what do we do? Remember, yep.
Mod it by 4 and then divide it.
Yep, mod it by 4, and then take the result of the mod, and then divide that by 2. Yep, there you go. Because once you mod a number by 4, what are the possible values of a mod 4? 0, 1, 2, or 3. Exactly. So when you divide that number by 2, you either have a 0 or 1. So that's how it works. Yep.
Another way of kind of thinking about it is if you're kind of flowing through this, you took the quotient, but you threw away the remainder, the previous stuff, and I wanted to call on that to try to hold the remainder, but I'm not allowed to.
Right, exactly.
So now you want the remainder, throw away the quotient.
Yep.
Isn't it the same thing as dividing by 2 and then multiplying by 2?
First divided by 2 and then multiply by 2.
Yeah.
You divide it by 2 first, then you multiply by 2. Multiply by 2 will only give you a 0 or 1. So divided by 2 is the same thing as a shift operation. Yes, that will work too. Yep. Because division by 2 as a binary number is shifting to the right hand side.
Yeah.
So you're shifting the middle bit so that it becomes the least significant bit. And then the mod operation says, you know, I don't want to look at the other bits, I just want to look at the least significant bit. So that works as well. So I'm going to write it up here just so that you guys know the alternative to do this. Okay. So the alternative for the middle one is, it is the floor of a plus x divided by 2 first and then do a mod 2. So that will work too. The division by 2 is right shifting so that the bit that we're interested in is now the least significant bit. And then the mod 2 is to say, okay, let's not pay attention to the other bits. We just want to look at the value of the least significant bit. So that works as well. Yep. The other one is basically doing we get rid of all the other bits and then we do a division. So it works out the same way. So the other side is going to be the same thing, except we're not dealing with 8 plus x, we're just dealing with x here. So it becomes x divided by 2, which is also a shift operation, and then a mod 2, which means we only pay attention to the least significant bit. So using this technique, the next one is actually not too bad, okay? Because this time we can say this is 8 plus x, the whole thing divided by 4. Yep.
Did you do the third item in C? Or for C, or like the third item, did we do the condition if it's not met, if it's not negative?
Which one?
We have the empty floor.
Oh, this one?
Yeah.
Oh, it's going to be the same thing here, except it's going to be x mod 4 divided by 2.
Oh,
So this would be x mod 4, and then the whole thing divided by 2, which works out to be the same thing. The mod is just basically getting rid of the more significant digits compared to the one that we want. The division by 2 is the shift operation. So you either get rid of the more significant bits first, which is what I do, and then you shift it to get to the least significant bit, or you can do it the way you did, which is to shift it first and then you get rid of the most significant bit. Okay, so this one using the first approach is to divide it by 4 first, which is a right shift by 2-bit operation, and then do a mod 2, which is the same thing as extracting the least significant bit. And then the other side is the same thing, except it's division by 4 first, and then do a mod 2. All right. Are there any questions about this?
So the same modification for C is the same for D. 8 for E plus X over.
Actually, I think I can simplify this a little bit. I think we can reduce the whole thing to just x mod 2. Because x mod 2 will give you the least significant bit right away. There's no need to do the division first. In fact, doing the division first will give you the wrong result. So that's the right answer right there. And the whole idea in both approaches, my approach and also your approach, in both approaches, division by 2 is the same thing as right shift by 1 bit. That's basically one of the premises. And then the mod 2 is the same thing as ampersand 1, which is bitwise and with 1. So these two are the same thing, and then these two are the same thing too. Yep.
Well, this works because if it's 6, then your D bit will still be what?
Say again?
If your X is 6, will D of X still work properly?
Okay, so if x is 6, okay, so let's plug it in. 6 is less than 0 is false, right? So we go to floor of x mod 2. X is 6, 6 mod 2 is a 0, which is correct. The least significant bit representing the value 6 is in fact the 0. Yep.
If you write this with if-else statements, it would be way easier for you.
Sorry?
If you write this with if-else statements, it'll be way easier for you. Because you, if it's greater than, if it's positive, like if it's negative, then you know to set A equals 1. So you would just have that as your first set, and then you go on, and then you just keep doing that. You just, like if it's straight, you just.
But then you cannot put it into this format. You cannot come up with a for tuple. You will have to use local variables to store the individual bits, and then you combine all those into your for tuple. It will work. I mean, it's just that if for notation purposes, then you will not be able to make a closed form in one single representation.
Yes, yeah, that's true.
Yeah.
Is that how you would write the answer though? It's like,
Oh, the
how would
answer?
it-
Oh.
Yeah, but it's inverse form, but how would you fit all of that?
This won't be the answer. You know, the answer is one way to do it. Okay, if you do not like to do it this way and you just want one gigantic closed form, then the answer is going to be, when I do something like this, you know what is going in between is going to be quite nasty. Okay, so you'll end up with that, and you end up with the B. And then you end up with a C. Take your pick, you know, whichever one you want to use is fine. And do the indentation. And then here comes D. There you go. But since you asked.
Is it, I mean, aren't you kind of mixing notations with this though too? Because you're using the floor function and like maybe a mathematician wouldn't be able to. You're kind of mixing like I guess standard math notation with programming. So why would?
Function's a thing in C.
No, I know it's a thing in C, but I'm talking about like in the math class.
Although they
No,
don't spell
but
it out.
but
it is a thing.
I have to spell out because this is a text editor. I cannot do this in place of floor of something.
Not unless we were on Moodle and you were doing the webpage.
Yeah.
Right. But you guys are going to handwrite this, so you can definitely do the floor symbol. And then mod, which we know as the percent symbol, is known as MOD to mathematicians. So they know this stuff already.
Well, what about ternary?
They do not have ternary, they do have if. So they have if, and then they specify a value here, and then specify another value over there. There are ways to express the ternary operator in math. This is how they do it in the recursive definition of factorial. There's a way to do it. It's just that since we already have C and C++, using a ternary operator, we can just use that.
Would the first line be an acceptable answer?
Say again?
The first line, wouldn't it be an acceptable answer?
The first line.
Yeah.
Just the AX, BX,
Yeah, that would be fine, because you're just deferring the actual definition with another function.
We have to include the definition, the AX, BX.
In that way, you'd have to have it underneath.
Correct. If you just give me this, that won't give you much points.
Because, I mean, compared to the homework assignment that we had, negative, or inverse of F,
Yeah.
it was acceptable just this time.
But that's because we have already defined what is F and what is F inverse. You are defining F3 and F3 inverse. But in this case, A, B, C, D are not defined yet. Yep.
That's another class in the past with this question on their exam.
No, this one was just a practice exam. The one that we experienced on Tuesday, that was the actual exam where this was the practice exam. Yep.
So in future reference to test questions, are we allowed to use C notation, C++ notation, even if it's not explicitly stated, if it seems like it would help us answer
It
it?
would be good to ask me first, but yes, you can make that assumption. Because this one explicitly states that you can utilize any operator in math or C and C++, excluding bitwise operators. Yep.
How do you know that 1010 is -6 and not 10?
because I teach CISP 310.
But like, how do you differentiate between, -6 and 10? Because they look.
That's a good question, and that's a good question to ask in CISP 310. The bottom line is 1010 is really just 1010. There's no particular meaning to the two, especially when you look at it as a 4 tuple. It's just literally 1, 0, 1, 0 as 4 things inside the 4 tuple. There's no particular meaning to it, right? So that's why we need f as a function. So what this function really is doing, when you think about this a little more, what this function is really doing is it is giving you one way to interpret 4 bits
Alright, okay, I got you.
to turn it into an actual value that we can use in calculations.
Oh, I see, okay.
And then when you look at 8 bits, it's a different story because 8 bits can also be interpreted as a number, but when you apply it to a printer, the function is not mapping 8 individual bits to a particular value. It is mapping it to what? What does ASCII code do?
Sure.
Into a printable character or something that you can send to a typewriter or a printer. So the function is what is giving the semantics or meaning to the zeros and ones.
Okay.
Yeah, but I think that's a really good question. It really helps to clarify the concept between just zeros and ones and the meaning of the zeros and ones, so it would actually benefit people in CISP 310 or people who have already taken CISP 310, can still benefit from this discussion. So it was a very good question. Good job. All right. Any other questions about this practice exam?
Have you ever had a question on exam that required a ternary operator?
Yeah.
More specifically for
I
classes like
cannot
this.
remember what I used as the solution of this one. I'm not really sure whether I actually used the ternary operator or not.
What other way would you have to do it?
I don't know yet. I cannot remember how I solved this problem last year. But this is the solution that I come up with. And you guys said, okay, can we go over this one? Sure, we can go over it. Remember, doing buggy. Any other questions? No other questions? Okay. If there are no questions, we are going to move on. We are moving on to, we have to finish predicate logic, and I got some stuff to show you guys. Okay, so with this one, I added a little bit to the material that is already on it. Okay, so there's the predicate inference, stuff like that. Then we talked about prologue, okay? And so this is all the stuff that we talked about already. We have not talked about substitution yet, okay? So that's the next topic to talk about. So what we'll do is instead of talk about all this dry stuff here, what we'll do is, I think it's best for me to copy and paste this code into a file first for 2 purposes. So that's what I'll do first. So is I'm going to take a look at this entire program, starting from here, and turn it into an actual program. Where's my text editor? I'll start a new one. Okay, so I'm going to start a new file, and we'll call that Jedi.pl. And all I'm doing is I'm just copying and pasting all this code here. Paste like that, have to paste like that. Okay, there we
Can't
go.
you also right click? Wouldn't right click and just paste it in general?
Yeah, you can do that too. And then we put this here. It's the middle click, not right click in Linux, but it does the same thing. All right, so let's just take a look at these 3 clauses in prologue. In prologue, case is very important because anything that starts with the uppercase is automatically a variable, okay? Anything that starts with a lowercase letter is automatically a constant, okay? It's basically an element in the universe. Remember the discussion of the domain, the universe of discourse, okay? So anything that starts with a lowercase letter is automatically an element in that universe. But if it starts with an uppercase letter, it is automatically a variable. So in this case, I will turn on the line numbers, so this way we can refer to the line numbers. Yes?
Are you talking about that from the perspective of like this class, or you refer to some other programming language?
Not from this class.
Okay.
Yeah, because after all, practical calculus is the mathematical foundation of Prolog. So without Prolog, why would we wouldn't be interested in practical calculus at all? If you have to do everything by hand, then it doesn't have a value anymore. So the whole idea of practical calculus is to create a formal mathematical system where it can be mechanized. Okay, use a computer to do all the processing for you. Okay, so looking at this particular program, the first line is an assertion. It is a predicate. It is basically saying is a Jedi, which is a predicate, in parentheses Obi-Wan. Obi-Wan is now an element of the universe. And it is saying that this is true. Okay, this clause is true. This predicate is true. Okay, it's a given fact of this universe that Obi-Wan is a Jedi. Is that okay? Yes.
So what if it was your name instead of Obi, and would that make you Jedi?
In this system, it would make me a Jedi. Yeah.
Sure.
That's how we assert that Tack is a Jedi. If you say is a Jedi in parentheses, lowercase t, AK, then I will become a Jedi. Okay? Or the representation of me in this system becomes a Jedi. Yes.
I want to be a Jedi.
Mickey is a Jedi, right? Okay, so the second one is the same thing. Line 2 is asserting that Luke Skywalker is a Jedi. Okay, so these are, it's kind of the same thing as what we have in the iota set. Okay, because these are given facts that is true. Okay. The third line is the interesting one because it has a variable. Okay, it is basically saying for all x in the universe, is a Jedi, x implies can use lightsaber for the same element of the universe. Let me say that one more time. The implication is the other way around. It is the right-hand side that implies the left-hand side. In other words, it is saying for all x as an element of the universe, is a Jedi x implies can use lightsaber x. Is that okay? Yep.
Why are we reading it from right to left?
Because later on we will see the right-hand side can have multiple components. You can say blah, 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 and blah, 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 and blah, blah, blah implies a certain predicate. And having it on the right-hand side makes it easier to type. Is that okay so far? Okay. But this is the reason why there is a mechanism called substitution. In other words, if you ask, okay, because does this program spell out, okay, explicitly that Obi-Wan can use a lightsaber? It's not spelled out, right? So how do you know that Obi-Wan can use a lightsaber? From your perspective, you know, right? Because you know that Obi-Wan is a Jedi. But from the mechanical perspective, how can a computer look at this code here and say that, oh, I can come to that conclusion that Obi-Wan is a Jedi? I mean, can use a lightsaber. It has to do substitution. In other words, it is going to, if you ask the question, can use lightsaber Obi-Wan, then it will either tell you it is true or it is false. But how can you find out whether it's true or false? So what it does is it will first substitute X with Obi-Wan, but that will also change this X to Obi-Wan. And then it will see, okay, can we confirm is a Jedi Obi-Wan is something that is true in this system? So it will do it recursively, okay? It will look at this, it will start with the thing that you want to prove, and then it will say, okay, what conditions has to be true in order for that thing to be true. Then for each one of those things, it will look and see if it can prove it is true. Yep.
Is this syntax for Prolog, when you throw a variable, it's a question, and when you throw a constant, it's a statement or something?
Yes.
Is that how that works?
Yep. So what you can also do now, okay, since this is now in the file, we can now give it a try. Okay.
What's the
Say-
period at the end of the line? That's like a line ending line.
Which one?
Semicolon. The
The
dot.
period.
In this one here?
At the end. No, at the end.
That's a period.
Yeah, but what does that signify?
It's really just indicating the end of a clause.
So it's like a semicolon.
Okay, it took me a little bit of time to process that because a semicolon is not exactly a terminator. It is,
Statement.
it turns an expression into a statement.
Yeah.
In this case, the period is acting as a terminator. Okay, when you see the period, that's the end of the current predicate.
So it's more like an end curly brace.
It is, okay, it's
Ending
more
the
like
scope.
a semicolon in the context, well, okay, you can call it a semicolon in C and C++. Yeah, go ahead.
So it is mandatory that we have the period
Yes.
at the end of the statement.
Correct. So each one is a rule. Line 1 is a rule, line 2 is a rule, line 3 is a rule. So each rule has to end with a period. Okay, yep.
So what would happen when we have the period?
Then it will think the next line is a part of this line, which is probably going to cause other syntax errors. All right, so, yep, go ahead.
Is the idea of substitution, is it kind of like inheritance?
Kind of like what?
Inheritance?
No, it's not. It is not. It really is just pattern matching. You have wildcards, and it is going to say, okay, what can fit this wildcard? So X is kind of like a wildcard here. Okay, let me show you what I can do with this file first. Okay, I think that might answer many of your questions. I put in SWIPL, which is a certain implementation of Prolog, into my Linux system. So to read in the file, it is just JEDI, close square bracket, the period. Okay, it has just read in the source file. So now I can say, can use lightsaber, and I can ask it about someone who's not in the system, okay? Sorry? Oh, saber, okay, saber, okay, there we go. So I can ask that question. I can't remember whether it's a question mark. Okay, it says it's false, okay? I cannot use a lightsaber.
So close.
Okay, so let's ask about Obi-Wan. Is that my right spelling? It says it's true. And we can confirm Luke Skywalker. Also true. Yep.
Can you also do the, can you validate if they're a Jedi at this point, or do you add that another?
It's already affirmed that Obi-Wan is a Jedi because it read the file. It read the file that contained the entire program. Now this, go ahead.
Would you be able to add another name? So like.
No, you cannot add anything else at this point because all the rules, including quote unquote the facts, are read when we did the square bracket Jedi. So you cannot add anything at this point. You cannot assert any new facts in the system, but you can ask questions related to the facts that are already established. Now, this is one thing that is really cool that you can do in Prolog. Yeah, go ahead.
Can you go backwards and say that is Obi-Wan, is Luke Skywalker a Jedi?
Yeah, you can do that. But I'll do this first, okay? And it doesn't. Okay, only show me one. Okay, because this is basically just asking, can you show me one person who can use a lightsaber? And it says Obi-Wan can use a lightsaber, but it doesn't enumerate and show you all the people who can use a lightsaber. Yep, go ahead.
Why did it return true for underscore?
Say again?
Why did it return true for underscore?
It means there is at least one person who can use a lightsaber. That's all it's saying. Okay, doing okay so far. Yep, go ahead.
I was just gonna ask if there was any way to make it greedy, so kind of like in regex.
I cannot remember how to do it. I remember that Prolog can actually find all the answers, but I cannot remember how to make it do it.
Perhaps an asterisk. I think that worked.
I don't think it's asterisk. I mean here.
Yeah.
No. All right. Oh, to answer your question, yes, you can ask questions of is a Jedi, and things that are already affirmed. Okay, so we can say Obi-Wan, and it will just say it is true. Yep.
I'm wondering why you put y and you gave y this Obi-Wan. You defined x, but you didn't define y.
Right, but that's because I use y here. Because I use y as an unbound variable, so it basically, it will substitute y with something until it works. So the first one that it does is to substitute y with Obi-Wan, and that rule, turned out to be true for Obi-Wan as y, and that's why it comes back and say, when y equals to Obi-Wan, it works.
Is there a way for it to show Luke Skywalker in that? If you do it that way?
Not with an unbound variable. Yep.
So you can only use one unbound variable, you couldn't do y, comma, x, and have two unbound variables.
But then they become different unbound variables. They become parameters. Remember, they're the first parameter, but the predicate only expects one. So you cannot take on y and then comma x. Any other questions? All right, so where is the substitution coming in? Okay, let's go back to the source file. Okay, let me get rid of this, get back into this file. So the substitution is when I ask, can use lightsaber Obi-Wan, okay? Then it will substitute Obi-Wan with y here, and excuse me, this is x. And that will in return also substitute this x with Obi-Wan. And that turns out this, once x is Obi-Wan, now it is an established fact here. And that's how we can confirm that Obi-Wan can use a lightsaber. So substitution is really just what it implies. It is really just saying, oh, let's go ahead and substitute the variable x with the word Obi-Wan. But when you substitute x with Obi-Wan, you have to do it for the entire rule. So that means the one on the left-hand side, you have to change x to Obi-Wan. The one on the right-hand side, you have to change to Obi-Wan as well. So your new problem becomes confirming is a Jedi Obi-Wan is true. So you search through all these rules and say, can I establish that Obi-Wan is a Jedi? And that one was easy because we have a stated fact here that Obi-Wan is a Jedi. But that doesn't have to be direct like that, because I can also have is a Jedi being a rule and then use some other conditions to specify who can be a Jedi. Yep. Mm-hmm.
Okay, so I'm a little confused on the free variable.
Mm-hmm.
In your program, you have x, and I don't understand how y came into play.
Okay. So in the program, x. Okay, let's see what this really means. If I were to write out in mathematics, in mathematical symbol, this one is basically saying for all x in the domain or the universe, okay, in the universe, is a Jedi, x implies can use lightsaber x. Okay? So the last line, line 3, in mathematical terms, is saying for all x in the universe, where universe is the set of all the things that we have to consider, in parentheses, is a Jedi x, which is a predicate, implies can use lightsaber x in parentheses.
Okay, so you could have used any letter, capital or
That is correct. No, they can only be uppercase
for variable, yes.
for variables, yes. But it is not a free variable because the for all part is implied already. Yep.
So when you set an unbound variable such as y, it'll go through and into a
Yeah.
to that, what the first thing I found that feature?
Right. And if I remember correctly, there is a way to make prologue to find all the possible answers that can make the predicate true. I just cannot remember how to do it. Okay. Are there any questions about this part? Yep.
Yeah, I'm sorry. So in your running of prologue, is a Jedi Y returned Obi-Wan, correct?
It requires, yes, it requires the Obi-Wan. Well, that's not what I asked. I asked, it can use lightsaber in parentheses 1, and then they came back with the answer of Obi-Wan can use lightsaber.
Not, if immediately after that you put can use lightsaber W, would it still return Obi-Wan, or will
Yes, it would still return Obi-Wan because it is triggering the very same mechanism every time you ask that question.
But then now Y and W have an identity now, correct?
But the binding of Obi-Wan to Y ends as soon as that query is answered. So Y is not a persistent variable. It goes away as soon as the query is over. Yep.
If we had done Luke Skywalker first, it would return Luke Skywalker?
Yeah, I think so. Because it will just look for the first one that returns with the correct answer, then it's done. And that's not a bad observation, okay? Because that's exactly how it works. So we'll go ahead and reverse the order of these two definitions, run the program again, and then the conjecture is it's going to return Luke Skywalker as the first Jedi who can use a lightsaber, right? Okay. So we'll go ahead and give it a try. In Jedi. Give it and ask, can use lightsaber. X will work too, and this time it does just come back with Luke Skywalker. Now it's waiting for me to do something, and last time I pressed the enter key and it ended. So I'm thinking that if I press some other key, it will give me other answers. There we go. I pressed the space bar. That's it. So if you press the space bar, then it will give you the other possible answers. Which is one really cool feature of Prolog is it doesn't give you just one answer. It will give you all the elements in the universe that can make this true. Is that okay so far? Okay. So let's go back here because I can see that some people in this class are a little bit interested in Prolog. Okay, I can see that you are going like, this is kind of interesting. I might want to spend some time to look into this. This particular version is called SWI Prolog. So if you just look through a search engine, it's the first entry, and you can download it. It is available in all platforms. So let's see, where is the stable release? So it's got Windows, it has Linux and Windows. It doesn't seem to have a Mac. Oh, there we go. Mac OS 10 also. Yep.
What is the practical application for Prolog?
Practical application of Prolog. Well, Prolog is used a lot in AI, artificial intelligence applications. So anytime you have a system where you can specify a whole bunch of assertions of predicates, and you have to ask questions that has to kind of reason it out to confirm one thing, then Prolog becomes useful. But to answer your question, I'm going to cheat. Okay? Practical application of Prolog.
CD or something? Like CD or...
Okay, the first link is not, this one is not bad. Dr. Dobbs is a fairly respected journal or magazine, even though it's a little bit dated. So it says right here, it is no longer confined to research labs. It is now considered to be a powerful tool for the development of commercial applications.
From
So-
1993.
Sorry?
The future is now with this thing.
Yeah.
Where?
20 years old.
Oh, the source.
It's even older than first thought.
An AI expert.
Let's see, 93. I got my degree in '94. So it's about the same time. Prolog is an interesting programming language. It is, in many ways, a political competitor of Lisp. Have you guys heard of Lisp? L-I-S-P. It stands for list processing. Okay, these were both AI or artificial intelligence programming languages. They're really great for reasoning. Okay, you can see predicate calculus, can be used, in reasoning. Okay, Lisp is good at list or symbolic processing. So back in those days, I would say the early '90s to probably the late '90s, there was a academic race between the United States and the Japanese. So both countries were building, fast computers for AI, well, fast by standard back then, for AI applications. So there was a boom in, AI or artificial intelligence research during that time. So I would say the '80s is the prime time of AI research, and then it declined steadily, thereafter. So when I was working on my dissertation, which is in the AI field, the entire AI field was dropping off the map. I had two advisors. I had the first one, then I fired him. I get the second one. Neither got tenured. So after I graduated, both professors, had to leave because neither get tenured. And that's basically telling you what is, how AI went in the middle part of the '90s. But I think it started to pick up again. Okay, if you think about Watson, IBM Watson. Okay, I can see some people nodding and other people not so sure what it is.
Siri.
Do you guys want to? Sorry, go ahead.
It's similar to Siri and other.
It's a little bit more sophisticated.
Yeah.
Okay, so if you look up IBM Watson.
You know the Jeopardy did it?
Yes, it beat a person. It beat two contestants to win a Jeopardy match. But it is not really just a fun thing for IBM to do. They're not. It's not really just a showcase project anymore. Watson is now, or the technology or the techniques behind Watson is now being used to fuel not only business decision making, but also they try to apply to the medical field as well. So if somebody can accurately describe symptoms, okay, the reasoning engine of Watson can help diagnose what is causing the illness. That has long been a holy grail, not holy grail so much, but that has long been an objective of the AI field, is to be able to apply the techniques so they can automate certain things that only, quote unquote, only people can do. And Watson is getting one step closer. Compared to Watson, IBM also had Deep Blue in the past. What does Deep Blue do? It only plays chess. Okay, it's very good at it, right? But then when you look at playing chess and solving real-world problems, there's a big disconnect, right? Just because somebody can play chess really, really well doesn't mean that person has general reasoning skills. Exactly. But Watson, on the other hand, is capable of doing kind of fuzzy reasoning. When you think about playing Jeopardy, a lot of the questions to us are not ambiguous, but to a computer, it is very ambiguous. There can be multiple answers, and it has to pick the right one. And then when it plays the game, Watson did not have connectivity to the internet. So everything was already downloaded, indexed, stored when Watson played the game. So that's kind of interesting because now you have something that can just use it based on what it already knows, answer the questions. Yep.
My favorite thing was they incorporated Urban Dictionary into his language, and he started swearing at the researchers, and they had to take it out.
Oh, okay. Let's see that.
Should be interesting.
Well, you can see that already.
Probably a bad decision.
IBM's Watson memorized the entire Urban Dictionary, then his overlords had to delete it. What is shard?
The $36,000 question.
Yeah. Oh, that's funny. Right there, Watson couldn't distinguish between polite language and profanity, which the Urban Dictionary is full of. Well, that tells you something about, when someone says, oh, you're quite urban. So what does it mean to be suburban now?
Apparently it's bullshit.
Below urban? I'm sorry?
I said apparently it's bullshit.
Oh, bullshit. But that is kind of interesting because depending on the stock of the knowledge that Watson begins with, it can adapt. Okay, you can just take that into consideration and start to make use of the knowledge that he has gained.
They should have let him keep the Urban Dictionary stuff, but put a very tight constraint on how he was allowed to use it, because it could be useful in future talking to people who use slang and stuff like that.
Oh, so here's the multi-million. This is a $200 million idea for those of you who are creative. Remake 2001: A Space Odyssey, but with HAL integrating the Urban Dictionary. L9000, instead of saying Dave, don't do this. Dave, F off. You're not getting back on the spaceship. That would be kind of funny. Just remake the dialogue. Just remake the dialogue. Just keep the movie the way it is. Keep the background music. Just remake the dialogue. That should be very interesting.
That probably exists on YouTube somewhere.
That may be, but 2001 is not a very popular movie to begin with. Yeah. So are there any questions? I'd like that question. What is the practicality of predicate logic? Prolog is not the engine behind Watson. Okay, that's not what it is. But the studying of prologs, the studying of predicate logic and stuff like that, can help you, make AI work. Now, AI never works by definition. Okay, artificial intelligence never works because once it works, it is no longer AI. Okay, let me ask you a question because you guys are a new generation, okay, compared to me. When I was in university, speech recognition was AI. Speech synthesis was AI. Pattern recognition was AI. All the things that you take for granted was AI. And then when I ask you today, or take anyone off the street and say, what is artificial intelligence? Is Google search being able to listen to you and come up with the answer and read the answer to you? Do you consider that artificial intelligence? Most people will say, no, it's just an app, right? So it's a moving field, it's a moving target, and by definition, by the time it is matured as a commercial product, that topic, that research is no longer artificial intelligence. It's always the next thing. It's always something that people can do and computer cannot do just yet. That is research in AI. Is that okay? Do you guys kind of get a feel of it? So given that, do you still want to get into the field of AI? Which is always that one extra thing that you want computers to be able to do, but not quite yet. I think the next presidential candidate, should make use of Watson and integrate an expanded version of the Urban Dictionary. Or we can do it the opposite. We can do it exactly the opposite way. We take the conversation of all those debates and put that into Watson. Then it's no longer artificial intelligence. It is artificial. Whatever you want to use the words, yes. Yep.
Is AI dangerous?
Like what?
Is it dangerous? AI.
Is AI dangerous? Okay, that's a good question. I know some of you have to go home, but is AI dangerous? That's a very good question because we have watched a lot of sci-fis like Skynet. What is the name of the computer in the Matrix?
matrix, right?
Just a matrix? Okay, the matrix. Okay, so we always fear that computers or AI will get to a point where it will come back and say, okay, I can either enslave humanity, or humanity poses a threat to me, and I have to exterminate humanity, right? And then there's the movie AI itself, where the robots worship humans because we were their creators. Remember the last part of AI? How many people stayed awake the entire time? Okay, most people cannot. Okay, I think it's a moot issue because I think by the time computer technology can get to that point, we'll be more integrated into the system anyway. And besides, if a computer is really, really smart, it would not try to fight or deal with humanity. It would just build a spaceship and launch itself into outer space and say, thank you for the fish. Well, thank you for the fuel in this case. I just stole 20,000 tons of your rocket fuel. Thank you.